had that experience where you go to put your socks on in the morning and you find a big hole in the toe? Yeah? Well, astronomers recently had a similar experience, except not with their socks, but with the universe. But why is a big hole in the universe interesting anyway? Well, to answer this question, we need to go all the way back to the Big Bang. Now, I'll just say this, the Big Bang is only a theory of how the universe started. Nobody was actually there, nobody saw it, but it's a theory, and it's pretty well accepted at the moment. So in the Big Bang, the universe went from being really small to being about universe-sized. And in it, things were created, stuff that we can see and some stuff that we can't see. Now, it may interest you to know that astronomers don't know what 3/4 of the universe actually is. Now, if you ask me, that's pretty slack. But it's alright. Don't start throwing off the bridge yet. Astronomers know what 4% of the universe is. Yeah. So 4% of the universe is stuff like tables, chairs, people, Earths, suns, and galaxies. So in this room, if everybody in this room was the universe, about half of Mike would be what astronomers actually know about. Astronomers also have a pretty good idea of what 1/5 of the universe is made up of, but they've never seen it. They think it acts a bit like matter, that it helps galaxies stick together, but nobody's ever seen it. So astronomers called it dark matter. And in this room, you 3 people over here would be dark matter. The rest of you, nobody knows what you are. Astronomers have a pretty good guess that it's a thing they call dark energy. Now, dark energy is something that actually makes a difference in the universe, hence why astronomers needed to come up with something. They couldn't just say, it doesn't do anything, so we'll just ignore it. So what dark energy does is, remember how the universe went from really small to really big, so it expanded, and it's still expanding? Well, dark energy actually causes the expansion to accelerate. So instead of going at a steady rate like this, it goes faster and faster and faster. And so that's why they needed to come up with a theory of dark energy. Now, who recognises this picture? One? Yep, a few people. Okay, good. So this picture was taken by a satellite called WMAP, which stands for the Wilkinson Microwave Anisotropy Probe. And you need to have your teeth in when you're saying that. So it's a baby picture of the universe that shows what the universe was like a few 100,000 years after the Big Bang. And it shows temperature differences. So the red and the yellow show relatively warm areas, and the blue and the light blue show relatively cold areas. So this, I should have said, is a picture of the whole sky. So what the northern hemisphere people can see and what we can see, it's been flattened down onto a flat sheet, which is why it's kind of oval shaped. Now this particular picture and the effect that it shows has a reasonably interesting history. Its predecessor, the predecessor to this picture, was taken by a satellite called COBE, which stands for Cosmic Background Explorer. And the people who took the picture, John Mather and George Smoot, won the Nobel Prize for Physics last year. People who first managed to take any kind of picture like this, back in the 60s, that was Arno Panzais and Robert Wilson, also got a Nobel Prize in about the 1970s. However, the guy who actually used his brain and a piece of paper and a pencil to work out that this actually exists in theory, he didn't get a Nobel Prize. So, let that be a lesson to you. So, this map shows temperature differences, like I said. And this spot here is the coldest cold spot on the whole map. And if you wanted to look in the actual night sky and see where this was, you'd need to look roughly in the direction of Orion. Now, so what's so special about this coldest cold spot? Well, astronomers can't actually explain it. They've come up with this convoluted, roundabout, it's something to do with probably this. And they don't actually know. But, you remember how I said astronomers recently found a hole, not in their socks, but in the universe? Well, who wants to take a guess whereabouts this hole was? Yep, that's right. Oops. Oh, never mind. Okay, so they found a hole, and it was a big hole. And so what? And also, what it might be interesting to know is how did they find it? But let's start with the big. Okay, this is a big hole. Astronomers like to measure their distances in light years. You may have heard of this. So this is the distance light travels in 1 year. Now, if you were to shine your torch at the moon, it would take about 1 second for somebody on the moon to notice. So the distance to the moon is 1 light second. The distance to the sun is 8 light minutes, and the distance to Pluto is about 13 light hours. Now, you might imagine we're not even close to the size of this hole. So let's go a bit bigger. The size of the galaxy is 100,000 light years across. Now, when it comes to these big numbers, I tend to think of it in terms of money. I can imagine $100,000, and that's pretty big. I'd be quite happy with that. But we're still not even close to the size of this hole. So let's go bigger again. The distance to the faintest object you can see in the night sky with your naked eye, which is the Andromeda Galaxy, is 2 million light years away. Yeah, I'm thinking about $2 million right now. But still, it's not even close to the size of this hole. This hole is 1 billion light years across. Now that is a Bill Gates sized hole. But what do astronomers mean when they say hole? Do they mean like a hole in your sock where there's basically no more sock? Do they mean a hole that's been made in a frosted bathroom window by somebody being careless with a cricket ball where you can sort of see through to the other side? Or do they mean like a hole in your lawn where there's basically grass and dirt and no grass in the dirt patch? Or do they mean something else entirely? Well, it turns out that this hole is more like a hole in your lawn. There's basically no stars, no galaxies in that patch, but it's not like we can see through to something outside the universe, which is kind of sad, but there we go. So, right, how do you find a hole in the universe? Well, this is where this picture comes in. They used this telescope, which goes by the acronym VLA. But I'll tell you what that means in just a second. So it's a radio telescope, rather like the dish in parks. And so as you can see, there are several telescopes, so it's an array. And they're pretty big telescopes, so, big array. But so the people who named this telescope said, right, it's an array, it's big, we don't want anybody else to get a jump on us, so we're going to call this the Very Large Array. VLA. So, it works by detecting radio waves. And radio waves are the sort of thing that when you turn on your car radio and you hear Radio National or whatever, that's the sort of thing it detects. But because it's looking out of space and the radio waves that come from outer space are faint, it needs to have a big dish rather than just an area like your car. Now, it's quite useful, but it turns out that matter, like the 4%, half of Mike, that sort of stuff, gives off radio waves in space. And because dark matter is generally found with regular matter, if you detect radio waves using a telescope, you can guess, or you can determine how much matter and dark matter is in any one place. So that's what the astronomers did. They pointed this telescope at that coldest cold spot we saw on the red and blue picture, and they found absolutely nothing. But what is the connection between the coldest cold spot and the hole in the universe? Well, astronomers think there is a connection, and they think it's to do with dark matter. And so this discovery of the hole in the universe is going to possibly finally help astronomers work out what 3/4 of the universe is made of. But if you ask me, there's a simpler explanation. I think this is probably more likely. Somebody just cleared the way for a galactic